All right, folks. This is the next lesson in the unit. Yesterday we were talking about adding and subtracting, or excuse me, multiplying and dividing rational expressions. Today we're going to be talking about adding and subtracting them. And anything with addition and subtraction, you always want to look for a common denominator. So you can look through this worked out example. I'm going to go right straight to the back side and just kind of start you off and show you the processes and steps behind doing that, okay? So I'm going to start you off in example one, and I'll have these written on a separate sheet of paper just so I can explain a little bit better. All right, so when we're adding or subtracting, the main goal is to make sure that we can match up our denominators. And anytime that you do that, you have to, of course, make the fractions equivalent. So if you multiply, the denominator by something to get it equivalent to that, then we have to multiply the numerator by the same thing. Before we do any of that, we have to make sure we can factor out anything on the denominator. So x minus 1 doesn't factor, but I can factor x squared minus 3x plus 2. And what goes into positive 2? Well, it's going to be 2 and 1. But since it's a negative 3, they have to add 2. That's going to be minus 2 and minus 1. And right off the bat, well, I can see that I have an x minus 1 here. So let's rewrite that. Now what I do is I leave a little bit of space with the fraction I need to add something to. So I'm going to do x over x plus x minus 1. I'm going to make some space to the right of it, and then I'm just going to write the fraction I had, 2x minus 1 over x minus 2, x minus 1. Now, in order to make these denominators equivalent, I have to steal, I already have an x minus 1 here, but I have to steal this x minus 2 and rewrite it next to this x minus 1. When I do that, now my denominators are suddenly the same. But I can't do that alone here on the denominator without adding it next to the top number. So I'm going to put it next to the x on the numerator as well. So when we steal from the denominator, we also write on top as well. Your restrictions are going to be the same as multiplication. We look for what makes the denominators equal to 0. So you can say, well, my restrictions in this case are going to be positive 1 and positive 2. So your restrictions are x cannot equal 1, 2, and while we're at it, we could do our domain. And we don't do our domain for everything, but generally speaking, if we have maybe 1 or 2 restrictions, that's a fairly simple domain to write. Just we say negative infinity to the smallest number, u, connect the two numbers, u, largest number to infinity. So just kind of get used to writing that, because some questions will ask for a domain and some will not. So it's always best to kind of know how to write them for any situation. All right, so finally, when we have our denominators matched up, when we're doing this problem, we have x times x minus 2. We want to multiply out anything on the numerator. So don't do anything leave the denominators factored, okay? But if I have x times x minus 2, we absolutely want to distribute that x. That's going to give you x squared minus 2x. And like any fraction, if you have the same denominator, we're basically going to add the numerators and put it over the denominator. So my numerators are going to be x squared minus 2x plus 2x minus 1. We want to look for any like terms and combine them. In this case, I have a minus 2x and a 2x. So you should recognize that those cancel out. And that's just going to give you x squared minus 1 on the numerator. Well, if you can, factor out the numerator. So you can recognize x squared minus 1 is a difference of two squares. And that's going to be x plus 1, x minus 1. So I'm going to rewrite that factored. And then I'm going to look for anything to cancel out at the end. So since I have an x minus 1 there and on the bottom, my final answer is just going to be x plus 1 over x minus 2. And that's way less simple, way more simple than what you have up here. So that's really the goal, is to try to get this in simplified form. X plus 1 over x minus 2 is the same. So that's example 1. All right, looking on your notes for example 2. Again, I'm going to have this on a separate sheet of paper. Another addition problem. In this case, we have a little bit more tricky factoring involved. These are going to be factoring by AC method and grouping because I have a leading coefficient of 2. So we'll have to multiply the 2 and negative 2 and the 2 and negative 5. So 2 times negative 2 is negative 4. And they have to, two numbers that multiply to negative 4 and add to negative 3. So that's going to be negative 4 and positive 1. Negative 4 plus 1 is negative 3, and negative 4 times 1 is negative 4. So remember, on these ones, you want to write that as 4 terms, 2x squared, break the negative 3x up into minus 4x plus 1x from these numbers here, minus 2 at the end. And let's do that with the 2 and negative 5. That's going to be negative 10 and negative 9. And it looks like negative 10 and 1 will break that up. So that's the breakup of the minus 9. And this is going to be GCF factors, so 2x from the first two. And that's going to be x minus 2. And I can't take anything out of 1 and 2, so I just put a plus 1, x minus 2. And that's going to give me 2x plus 1 times x minus 2. So that's what the denominator factors to. Over here, same deal. We're going to take out a 2x. And that's going to be x minus 5. And we're going to take out a 1, x minus 5. And so 2x plus 1 again, and x minus 5. So let me rewrite these fractions. Now that I have the denominators factored, it's going to be 8 over 2x plus 1, x minus 2. Leave a little space. I take a lot of space up when I'm writing these problems out. I really don't care. I mean, you know, I'd rather use a couple sheets of paper and have space to work than try to cram it all into one spot. But that's just me. Let's look for common factors. We have a 2x plus 1, so that's good. This has an x plus minus 2. This one does not. So I need to go over here and copy x minus 2 on the denominator, and I got to throw it up on top as well. So anything that you don't have from another fraction, we got to steal. This one has an x minus 5. We got to bring this over here. And we got to copy that on top. So if you look at these denominators now, they have all three of the same factors. We're good on that end. So at this point, we're going to have to distribute the 8 into the x minus 5 and the 3 into the x minus 2. So that's going to be 8x minus 40 over the denominator plus 3x minus 6 over the denominator. And it doesn't really matter which order you write the factors in. Add your numerators, combine like terms. That's going to basically combine to 11x minus 46, if I did that right. Nothing cancels out here. I can't take anything out of 11 or 46, so that ends up being my answer. Let's talk about restrictions. Usually I try to do that before I simplify it, but sometimes I forget. What can x not equal? Well, what's going to make this 0? That's going to be negative 1 over 2. Positive 5 and positive 2. So x cannot equal those values. So that is your answer when you simplify it. All right, look at example 3. Okay, this example has a subtraction. We don't really treat these any differently other than, we're dealing with negatives instead of positives. So if you want to pause it and try it and come back and check with me, that would be probably an easy thing to do for you guys. There's a couple approaches to this problem. So I'll give you the hard way first, and then I'll show you the easy way. First thing is you got x squared plus 6x plus 5. Well, that's going to factor to x plus 5 and x plus 1. So if I'm doing it the way that I just taught you, I'd be rewriting this as x minus 1 over x plus 5, leaving some space. 5x plus 5 over x plus 5x plus 1. And recognizing that I need this x plus 1 over here, I'm going to go ahead and write that next to the x plus 5 and the x minus 1. And so if I were to multiply that out, that's going to give me x squared plus x minus x, which cancel minus 1. So that's x squared minus 1 over my denominator. I didn't have to do anything with 5x plus 5, so I'm going to leave that alone. And because I'm subtracting, we do have to be very careful with that. We're subtracting all that. So it's really going to be x squared minus 1 minus 5x plus 5. But the 5 is at the end is going to get subtracted because it's being subtracted from the x squared minus 1. So that's going to end up being a negative 5. All right, well, that's going to be x squared minus 5x. I'm going to write it in order. And then the minus 1 and negative 5, that's a negative, is going to be negative 6. When I factor x squared minus 5x minus 6, I get x minus 6 parentheses x plus 1. That's right. There you go. So x minus 6, x plus 1. And I can say, oh, well, those x plus 1s cancel out. And so I have x minus 6 over x plus 5. Definitely not any more work or less work than the last one. But there is an easier way to do that. And so I'm going to go back to the original problem real quick and write that out. I want to show you something that maybe you picked up on or maybe you caught in class. Notice that on this problem here, I didn't factor out the 5 because the directions for these say just worry about the denominators first. But if I did, you would notice that I have 5 parentheses x plus 1. So if I have this factored and the numerator factored, you might notice that, hey, these both have an x plus 1. And if I cancel those out, I end up having the same denominator for both of these. Well, if I have the same denominator, I don't have to get like denominators. I can just combine the numerators. So that's going to be x minus 1 minus 5 over x plus 5. And guess what? That ends up being the same thing. So a little bit less work, a little bit less factoring involved, less room for making, careless mistakes. I try to look for those if possible when I do those. So let's look at the restrictions. What's going to make my denominator 0? Well, we can go back to the original problem. It's just going to be -5 and -1. So x cannot equal -5 or -1. And if you want to write your domain, that's going to be all real numbers except -5, -1. So -infinity to -5, -5 to -1, and -1 to infinity. So restrictions, domain, simplified answer. Well, there you have it. The next video will cover the last 3 examples in the notes.